So we're just here to share a bit about our journey of bringing our platform that can send more than 1 billion messages to AWS. And just a quick intro, I'm Yang Yu. I'm a Senior Director of Product Management for our Marketing Cloud Engagement platform. And here with me today, I have my colleague Omar.
Omar Jaber, Principal Architect at Software.
Yeah. So what we'd like to do is just take you through a bit about the kinds of problems that we solve for our customers, the business impetus that really helped us to choose AWS as a partner and to bring our platform to public cloud. And then Omar will talk a bit about the transformational journey that we went on from architectural principles as well as some of the key problems we had to overcome. Now, before we dive in, just a quick pit stop to remind you, Salesforce is a publicly traded company, so as such, this slide is just to note that please make purchasing decisions based on products that are currently available. Now, some of you may have seen our commercials about Salesforce at Super Bowl or the World Cup with Matthew McConaughey. You might just remember from those commercials, we're the company that doesn't work in the metaverse. We work in the real world and we help our customers solve real problems. But as such, Salesforce is a company that creates trusted enterprise software for some of the largest brands in the world, including the world's leading CRM product, as well as the #1 marketing cloud product by market share. Now, we have a large global footprint. And several years ago, we embarked on a journey to think about how do we expand our geographical reach to other regions around the world, as well as who are the right partners for us in the public cloud that share our #1 value, which is trust. And at Salesforce, trust is the key value that allows our customers to entrust us with their most valuable data. And so that's a very important characteristic that we look for in a partner like AWS, which provides industry-leading availability as well as security by design. And so with this partnership, we're able to help unlock customer success with our platforms and our joint ecosystem of services and partner companies that can help our customers implement their solutions end-to-end. It helps accelerate our pace of innovation with our customers. And we're building a trusted infrastructure that can scale to support our gigantic workloads. Companies are really embracing the digital transformation, and we've seen with the pandemic how all of the activity is moving online and moving into a digital interaction model. We've built the #1 CRM platform, which brings together all the data about your customer relationships so that all the different departments at your company can have the same view of the customer. And we've now brought this platform to Hyperforce, our public cloud infrastructure. We're in a new world where 85% of our customers are telling us that they're concerned about the impact of inflation that it's going to have on their customer relationships and on their ability to hit their sales numbers. At the same time, there's changing data privacy regulations and data locality requirements where you have to store the data in the region that it was generated and respect the wishes of customers to keep their data private and only used for the purposes that they authorize you for. At the same time, customer expectations are rising. Every customer expects to have the same great experience that they get when shopping with Amazon as they do in a retail store. And if you're standing in line at a hotel waiting to check out, wouldn't it be great instead of waiting in that line, you can just interact with the hotel through an SMS message and reply, hey, I'd like to check out now. Please send the folio to my email. Similarly, if an airline canceled your flight, wouldn't you rather just rebook using your phone instead of having to call in and sit on hold for an hour waiting for an agent to get back to you? So it's with these expectations that customers can often see how disconnected their data is when a company is creating an experience that really views you as just another number or another name on a list. And a great example of this is yesterday as I was walking to my hotel, I got a phone call from the hotel chain asking if I was interested in an offer to stay in Vegas for free. And I told them, I'm looking at your hotel, I'm about to go check in, And why are you calling me now about an offer to come to Vegas? I'm already here. And marketers are struggling with just the amount of data that they have about their customers. They're coming from all different channels and endpoints. How do you make sense of all this? Well, this is why Salesforce has created the Customer 360. Now with Genie, which helps to create more real-time experiences. Our platform allows all the departments at your company to have a single view of the customer, to have a unified profile to let you understand, I'm Yang, I work at Salesforce, I'm visiting Las Vegas for reInvent, and I'm staying at a hotel, so that you can have a great experience for your customers without having to dig through petabytes of data to try to create that unified view. And with our Marketing Cloud engagement platform, customers are able to achieve huge success with their marketing campaigns, where they can build a customer journey just to track as I'm leaving my home city of Seattle, getting on a flight, landing. They can build a digital twin of my journey to help guide me through along the way. Hey, your baggage claim is down in this section. Your luggage is ready. Your Uber is ready. And our platform is the leading platform that allows you to connect all of these channels across email, SMS, mobile push, WhatsApp, to create that unified experience that customers are expecting today. We're able to do this at massive scale. We're still in the middle of our Cyber Week, which is one of our biggest weeks of the year in terms of volumes. And while we surpassed 1 trillion messages in 2021, we've already surpassed 1 trillion messages this year, with more than 50 billion during last week alone. So it's a massive platform that we have developed over the years that we're now bringing to AWS with our Hyperforce platform. So by bringing Marketing Cloud engagement to Hyperforce, we're able to unlock data residency, provide massive scalability in the different regions around the world, as well as build out a trusted, secure platform with the right privacy controls built right in. It gives us greater agility to deploy our products where customers need it most. And our customers are then able to choose where they store their data, where the data is processed. And we're excited to announce that in India, we have a pilot available for our customers in that region. So I'll hand it off now to Omar to talk a bit about the architectural principles that guided us throughout this process and some of the challenges we had to overcome. Thank you.
Hi everyone, Omar. So they came to me about almost a year and a half ago and said, you're taking this 9 billion message a day platform and put it in AWS. I said, just hold my water, I'll be done. We're building the platform on what Salesforce calls Hyperforce platform, which is sort of a platform that sits on top of a public cloud and provides key principal elements for us. For us today, when we're transforming a trusted platform like our engagement platform, there are a lot of key elements that you would recognize from going to public cloud. For me, is one of the key elements that we'll touch on today and probably get more questions from you later on is what would you like to know more, was zero trust architecture and data protection, or data encryption everywhere. Yang touched a little bit about our global reach. We're deployed in about 12 different stacks across the globe, in Europe and the United States, and we just finished deploying in the US and India and the US 2 more stacks on Hyperforce and AWS. Deploying a single, like a data center on premise, takes about 6 to 12 months to build. The data center, equip it. Takes about 3 months to get the stack software ready and validate it and ready to go. Takes about a year from the time you say, I have a growth in a specific market, that market has a data residency requirement, and I need to be there. That will take you a year. By the time we're done with Hyperforce transformation in AWS, we brought it down to 2 months. I'll get you more details later on. I'll touch base on that one. When you transform a platform that have over 10 years, thousands of customers, and trusted, and it does considerable amount, it's a multi-billion-dollar platform, and it's not the only product for Salesforce, but it's one of our large products. You gotta have to put some level of objective you're trying to reach with that transformation, goals from that transformation. For us, there are a set of goals we wanted to reach. We wanted to make sure that we have parity for what we're deploying on premises. We wanted to make sure we achieve zero trust architecture, the same code base. The same code runs daily basis. People check on the same code line. They check it, they validate it, they deploy it on our data centers as well as in AWS data centers deployment. Doesn't differ. Different infrastructure for sure, but it doesn't differ. As well as adapt zero trust architecture. I'll give you a bit of a high-level architecture overview of the software. It is, at the high level, at the top, there's the application layer. This is where the journey builder orchestration UI sits that sort of takes and makes it easy for you to create a journey that tracks you across the platform. This is where the automation studios and reporting and analytics that you interact with as a user, the authentication, the login. This is the application layer sits right at the top. And this integrates directly with Engagement 360 for Salesforce. As well as on the left-hand side, you see it's a completely API-driven platform, whether for mobile, WhatsApp, email, transactional messages. Like for example, if you got a customer who's from an airline customer who has a lot of consumers and create a travel trip within Marketing Cloud, can easily call an API and says, send an SMS message to these customers, go from gate A to gate B. It changed. These are all API-driven. So our customers build a platform on top of our API to drive their workload or use our existing platform. At the center of it, you have the largest SQL Server deployment. It's a SQL Server cluster that hosts our customer data, their consumer data, and as well as some of their business logic, their configuration, their business rule. They're backed by other storage, big data solutions, but the bulk of the core of the product sits in SQL Server. And in the middle there, you see the compute cluster. The compute cluster are what deploys or what runs our own business logic. When the customer sends a message and say, you know what, I want to send a message to X. That message is not necessarily sent to X. It's sent to a set of audience within that engagement. And then we customize it, personalize it, and render it, and send it out. So that engine responsible for driving that, for example, last Thanksgiving was 9 billion messages a day. It was that engine. And that business logic runs in both. We have a mix that runs in Kubernetes as well as VMs. But it's still Windows platform based. So looking at this, when we're trying to transform this, our biggest thing is how could we take then this entire database cluster, which is the second largest one, that runs on our premise data servers on AWS, and how can I make sure that our customers will get the same performance, scale, throughput, and trust? And how can I achieve it? For us, looking at it when we started at the project earlier is the database servers, the clusters were the highest risk for us. We wanted to mitigate and mitigate it early. So that's where we focused on. We started with the same questions like everybody else. I have a database that runs trillions of transactions. We would do about 3 to 3.5 trillion transactions in Cyber Week, in 1 week. It's a large scale. We look at it and says, the typical factors comes in. It's a large database size. It's a lot of it, thousands of customers. And when I look at it and say, well, there's a lot of scale factors here to look at. There's I/O, CPU, and memory. But that you can map on any, as you go from first-party data center hardware, you can always map it to AWS. But what impacts our customers from other scale factors, such that I can say customer A sits in first-party on-premises, I will be able to take and model their workload in AWS and provision them and put them in AWS, and they should be able to get the same message throughput, rendering, customization throughput. How can I do that? We did that by looking at base scale factors of all our customers' population. And we decided on 4 scale factors: database size, log size, log write throughput, and IOPS. And based on that, we took our customers when we mapped them accordingly on how best to fit them on our database clusters. So what I'll do is I'll walk through some of these factors, and I'll tell you how we used each one of them to basically provision our customers some data. Most of our customers are well below 20 terabyte database. But we got a small percentage of our customers are well above 300 terabytes. Some are 100, 200 terabyte. But the largest customer, which drives most of your market, are well above 300 terabyte. And these customers' workload vary. Some of our customers, what they do is they run very few jobs, very few journeys, but they send a lot. And some customers run it the other way around. So these customers that run a few, they typically do OLTP workload. They have a huge amount of audience, and they push them through one journey. So your processing is high, your latency is very high requirement. But then you got some customers who have large databases, and they do a lot of data warehousing work before they do the send. Their sends is not huge, but targeted. So they differ at the end of the spectrum. Also, our customers tend to be different. Some customers come in, their organic growth is different. You get a customer who's new, it will take them a year, year and a half before their database starts growing, or their actual data set. So their data cluster is very small and takes a considerable amount of time before it goes large. So their organic growth is very slow. But then what happens is that you get other customers who come in from a different platform. And what they do, they bring in considerable amount of data with them. And from day one, they have a large data set. And you have to be able to adjust for it. So how you shard your data, how you deploy your data files, I mean, the number of files you deploy will heavily dependent on how much IOPS you do too, but that will get to that. So database size was critical to us. The other factor was log size. I mean, transactional logs is for a relational database systems is basically a ledger record, writing a record of every transaction is completed, just in case if it needs to recover it, or it needs to roll it back if something happens. The larger the log file, the larger it takes to recover a database, the longer it takes to run through recovery or rollback. We focused in two items here. One is, what are our sustained log size, and what is our peak log size? Our sustained log size and peak log size tell us two things. In our case here, our sustained log size is much smaller compared to our peak, which clearly indicated to us that a small percentage of our customers were driving most of the log size high, and that due to the fact that they were running considerable amount of long-running transaction that goes on for hours. In our case, it was easy to point out that it was our reporting. So as we transformed the system, we realized that we could not sustain that kind of workload unless we transform our reporting system to something else in AWS. So from that point on, it became clear to us that to lower our log size well below the 2 terabyte size, which is our key point. In our case, we have a primaries and replicas in AWS. Your deployment may vary, it could be different. You may have common status storage with a compute failover. We decided to go with a variability group, cross clusters, primary in one AZ, secondaries in each different AZs, and we fail over. It's critical for us that the failover and recovery between the primary and replicas to be instantaneous. It was also critical for us the log records shipping as well and replay and the continuous replay on the secondary does not leave the log open for too long. So reducing log file is critical to us. So we kept it at about below 2 terabyte. So during chaos testing, for synthesized testing for us, we see less than 60-second failover at 2 terabyte. We applied the same method to scale factor for log write throughput. What is my sustained rate versus my peak rate? And we wanted to, when we started, we had a higher number, much higher numbers of log write throughput. I mean, you're going to sit on the same instance, whether you're using a managed database solution or you're going to be deploying your own VMs and putting your own databases, you're going to be sitting on a limited resource. And regardless of how the throughput in the network and the back-end storage, you're going to you're going to be limited by the instance level. How much, you're coming out of the instance. Every instance has a limit on it. So, and you're going to be sharing that throughput and the instance on both the data and the log. So for us, when we started, we had considerable amount of much higher. We wanted to sustain a much lower log write throughput. And for us, for that one is, reporting also contributed heavily to that one. But the majority of our customers are well below the 100 megabytes per second. So for us, it wasn't a major concern to transform because of that, because the majority of our customers will fit within on the database clusters. The design that we wanted to have is to take our existing databases to an availability group in AWS. And we wanted to pack as many customers to reduce the cost to serve as we can. Doing that means we have to make a decision on peak versus sustained of various customers, whether how many we can fit in a cluster to maintain reliability, durability, throughput, and latency. At the same time, continue to have a decent cost to serve model. So for us, for log write throughput, we didn't do a lot of transformation beyond the reporting infrastructure, removing it out of SQL Server. The last one is IOPS. IOPS is everyone's favorite session. Everybody talks about IOPS. It's shared in this case between data and log. We started at a much higher IOPS in our case before transformation. What we discovered is very similar thing. Your smallest customer, your largest customer is driving most of their IOPS. IOPS is key. Is about 90% of our customer fit well below the 100 to 150,000 IOPS per second, which is where we want it to be. But for peak ones, we saw a lot of microtransactions. A lot of our API were driving a lot of our microtransaction, considerable amount of transaction running in the background, and constantly coming around and generating a lot of IOPS, both in data and log. So we optimized our APIs to constantly reduce the API log records writing and overall data write. A project at this scale, we had to phase it out. We had about 160 services to transform. These services, majority of them are over 10 years old. It's a well-trusted platform that's been running for a while. And our transformation was on Hyperforce, where it was not a Windows platform. So we wanted to phase the project. We started by introducing phases to the project. So we started by basically just taking our basic elements. For example, we run on Windows. We used AWS Active Directory service, but we had to integrate that service with existing Hyperforce identity model in Hyperforce. This is sort of the basic element, the basic phase. And then next phase up, we have to introduce engagement and foundational services that our application requires. And I'll go through a little bit more about details about the layering. Then we build the application. At that layer, we maintained focus mostly on just dev and test. We did not introduce yet stage or load testing. It is only when we went to phase 4, deployed to stage, we start focusing on scale testing and load testing. Synthetic workload tests were done way before to determine, based on the scale factor, which one we'll go with. And then we went to stage, and then production, we introduced our customer. So for us, it was get your scale, understand the data, understand your architecture, know what the key factors for it, the biggest risk. It was the data tier. Understand that data tier has four scale model. These will impact the customer scale. We picked the architecture of having a Windows failover cluster and Windows and availability group. The number of databases we pack is based on how will they fit within this model. Where they fit on the average versus sustained, whether it is IOPS, log size, log write throughput, or the data size. And based on that, we packed our customers. This allowed us to map, based on the customers, 4 scale factors in first party on premises into a cluster in Hyperforce and AWS, as well as a calculated cost to serve model. If you don't do that, then you run the risk of transforming to a platform, and you end up having a very high cost to serve model. or a platform that does not meet your requirement for scale. The next one is the service layering. I mean, we talked earlier about the phases. And the phases really just help you layer the system. So as you introduce, go from one phase to the another, you're incrementally adding more parts of the system and more risk. And these are sort of the concrete definition of the phases. So if you're an engineer and you want to go from on-premises to AWS platform, you expect yourself when you show up at the platform to work on, at least you will have CI/CD to work with, monitoring, logging from day one. Then we moved and engaged in identity, make sure the identity model, the storage is available. Then authentication, authorization, role-based access. So every layer built on the one on top below it, as well as introduces more complexity to the system as we go. The last one is core functional features and application logic, and eventually just your basic diagnostics and tooling. A few slides ago, I touched base on some of the fundamental goals we want, and one of the goals was to ensure that actually in a platform that runs so much workload that we provide the customer with, that as we've migrated from on-premises to Hyperforce and AWS, is ensure that this 10-year-old platform with a lot of assumptions being made on security and data trust within the data center, because security is by depth, so a lot of assumptions can be made about it. So we wanted to have a deep design cycle for all our designs to ensure that every single aspect of the product, regardless of when the service was introduced, is design reviewed. Design reviewed for CTS model, from security, what endpoints it has, what data it stores, what secrets it holds, what authentication model it has. So all services went through that process. Once the design is complete, it gets reviewed, as well as get reviewed by the security team. And if the review process goes through, either it highlights some elements need to be resolved. There are some, one or two cases where we had to redo a service because it simply would not be able to take it to AWS with all the security issues. So once it's approved, then it will go through the implementation details and it get transformed to AWS. This process went through every single service, regardless when it was introduced to the engagement platform, through that 12-month period. So we went through penetration testing, security reviews, as well as compliance testing, compliance reviews, and I mean, we passed the compliance with no audits to review. For zero trust architecture, it's a big subject, but the biggest focus for us was we wanted to make sure that data is encrypted at rest, data is encrypted during transit. We wanted to make sure that there is a MTLS, so mutual TLS between all nodes and all services. We made sure that any communication between us and external party, whether it's email, SMS providers, is all over MTLS to ensure that actually protection through and through. The only time two services communicate between them without encryption or MTLS if the services exist on the same EC2 instance. Beyond that, even if they're in the same virtual subnet, they will still communicate with MTLS. They require MTLS for communication. This one here, when we started the project, is one of the key elements is we assumed that at 160 services, it will take us at least a year to implement it. MTLS across all the services. It wasn't there. We had a subset. Like, for example, from compute to SQL, it was a TLS. And there was role-based access on premises. But in the case of MTLS across all services, it was not there. So what we did is we sort of put this little model, and we said, what kind of services we have, and what kind of protocol and communication goes between all the services. Let's draw it. Can we see a pattern? Can we build a library or two that will help us to implement this? 3 months, 2 engineers, done. So, I mean, so right now, the data as we deploy it in AWS, no two services within engagement platform run without MTLS encryption between them. Of course, we have VMs and we have Kubernetes. That means even Envoy still does not support that level of compatibility between them. So that part we also have to solve. Transforming in AWS, it has been an incredible experience. We started with the team about over 2 years ago. We went through our KPI model for modeling the data tier, our synthetic workload testing, our validation on their platform. It's been, I mean, one of the fundamental things we saw is your workload and synthetic workload testing, whether it is in the US stack or with an India stack, we continuously got consistent result. We worked with them with the ProServe team. Actually, they worked directly with us close for about almost 1.5 years, where they worked as part of the team, and it was actually been a great experience. The final architecture for the data tier has been, as I said, it was an availability group cluster over EC2s connected to IE2 storage. We went from about 14 months it took us from concept to production deployment, 160 services, 150 of them design reviewed. So we got a handful of them for tooling, didn't require design review. We have 100 security assessment, 2 production stacks. The data tier, as I mentioned earlier, it takes about weeks to a month to deploy in first party. It takes about 4 hours to deploy it in AWS end-to-end and validate it. So for us, that was a huge change. AWS has been a great partner for us. It's been every single aspect of it, every single service. Transformation has been amazing for us. If we wanted to transform and build a service, it was immediate for us. Building a new service, so it's always been a great partnership with them. Best in class, innovation, and definitely full stack trust. Thank you all for coming today, and thanks for giving me the chance to speak.